Okay, so welcome on the next presentation on the cloud deployment track. As you've seen on the previous presentations, there are plenty of MLOps solutions, software packages, options that you can choose from. One of them is MLFlow, definitely. So Kamil Owczarek from GFT is going to introduce us into MLFlow and how to use it actually. So Kamil, the stage is yours, and welcome on the presentation.
Hello, everyone. So I think we have the first slide covered by that. Thank you very much. So like it was said, I want to do a very quick run through of MLFlow. Now this slide, well, might not be needed for everyone in that it essentially explains what MLOps is during the MLOps track, right? But these are the things that I'm going to be going through, things like experiment trackings, things like verification and choice of the model, things like doing, well, some sort of integration testing, deployment and operationalization of the model in production. And then last but not least, I'm going to dig a little bit into things like model performance monitoring, potentially some retraining triggers, things like this. Yep, and of course, those are just keywords, right? But they don't happen in vain. They usually happen as a sort of process, and that's kind of how the demonstration will look. In real life, that process usually begins in some sort of sandbox for data scientists, where we get some data from maybe our production, maybe only from some external systems, right? And the first thing we do is we try to make sense of that data and try to construct some ML model that we are tasked with creating. And of course, this is a very, iterative and repetitive process. We will have to do many, many trials before we can figure out the correct algorithm, or maybe, well, we're not exactly going to get what we want, and we're just going to settle for, the best of what we have, right? So in that part, we will need model registration. Then, of course, once we either fulfill our criteria or we will have to, we'll run out of time and we'll have to settle for what we have. That what we have as the best solution will go into probably some sort of model registry. But that's not the end, right? Since usually the model is built on a small sort of data set and it works well there, but it usually also pays off to actually wire it with the sort of systems that are actually going to be applying it, like say some sort of big data or real-time pipelines in our case, and to have it tested in a sort of test environment before we decide to go to production with it. If it passes the test, then great, we can go to production. If it fails, then we either go back to our experiment registry and we try to figure out if we can make a better choice based off what we already have, or we go back to experimenting basically, and maybe we're trying to get some things differently so that we can then be provided with a better choice. So that's what I'm going to try to show you more or less. And of course, I'm going to be doing this with MLFlow. So just a very quick fact on this. MLFlow is, of course, an open source tool which aims at doing MLOps. It's done by Databricks, and therefore it's available as an integral part of their platform. But it's also just really a sort of application done in Python, and so you don't actually have to use it on Databricks. You can just go into your local machine, install it with a package manager like PyPy or Conda, and run it like that. I'm actually going to be doing that for the demonstration, so you see for yourself how that works. And the elements of MLFlow that I'm going to be talking through is definitely MLFlow experiments for experiment tracking, things like model registry, obviously the targets where we want to get to from experiment tracking, and some other appendages like the Python client, or the things specifically targeting Spark integration to show you an example of how that can be integrated in, say, data pipelines. And one thing which is difficult to show, but so has to be mentioned outright, is that I'm going to try to do a simple exercise of training a model while connecting everything to MLFlow, but I can only really do it in one framework in this short span of time. So I'm going to be using scikit-learn because, well, it's easy. But MLFlow actually has integrations for many frameworks. Pretty much anything which you can call like a major player in the Python machine learning frameworks league. It has an integration with MLFlow, right? Starting from things like scikit, Keras, going down to also the models done with the tools provided by major cloud providers like Amazon or Azure. So this is all there. And yeah, that's essentially it for theoretical intro. Let me now jump out of the presentation for a second and start showing you the actual MLFlow, right? I'll just quickly do this, and we can proceed. New. Yep. Okay, there we are. Apologies. So as I mentioned, MLFlow, you're essentially able to just install it with a Python package manager. So that's what I did with PyPy here. I just listed this as one of the dependencies here, really. This one is for core MLFlow. This one is for integrations for particular frameworks. And I also installed some stuff like Jupyter. I put all of that in a virtual environment pre-installed because, well, it would take a while for me to install it right now on the stream. And so once you have that, you're able to start your MLFlow. And it's actually pretty simple, right? You just do it like this. Again, I typed that in for time's sake, but essentially you have to type in MLFlow server, and you need to give two parameters. Both are different types of storage. One is the general storage, which if we want to do what we will be doing here, you have to use some sort of stuff like SQLite here. SQLite here. And then also default artifact root, which can be, let's say, the path to where the artifacts, so like, for instance, pickled models are stored. Now, in terms of what you can give here is, for instance, I think the most popular would be various kinds of object storage, like Azure Data Lake storage, or I think Google Cloud Storage is supported as well, right? As this is a local example, I'm just really using my local file system. And if you run that, what you get is essentially this, right? So that's the MLFlow UI on default port 500. Yeah, I'm going to show you pieces of that once I put something in here, right, of value. But you can notice the two main parts here: the experiment tracking and model lifecycle management, briefly speaking. So that's one thing. And then the second thing I am running is I'm also running my Jupyter notebooks, since well, at least with our projects, that's usually what data scientists prefer to use for creating their models, right? So that's here. Let me maybe quickly reload it. Okay, well, one more second, I guess. Maybe I'll just try to spawn from here. It's still going to be slow for some reason. Well, apologies for that. You have to give me 1 second for it to open. Maybe I shouldn't have reloaded this thing. Yeah, so essentially what I'm going to do now, let me explain it while it's loading. I'm going to take the most common I guess problem in machine learning for explaining simple stuff. So the iris data set, and I'm going to train a model on it and show you how I can easily intermingle MLFlow into it. In that, when working with Jupyter Notebook, you probably already know that you don't really want to keep that in Git, right? And that's not a good way of tracking what you do, right? Data scientists generally prefer to have this mutable Jupyter notebook and do the experiment in there. We run it and we run it. So MLFlow lets you do that in such a way that it basically enables you to embed calls to log and save certain parts of your experiments into MLFlow just as pieces of Python code, right? You're not doing any external work on this. You're calling Python methods from MLFlow API, and things will get saved. Okay, let me try to rerun that Jupyter. Apparently, maybe it has a bad thing. Right. Just going to apply the first principle of customer service here and to restart this. Right. Apologies for that. Okay, so hopefully this time we'll have more luck. Yep, thank God. Okay, so as you can see here, I'm just loading my iris dataset, yeah, displaying the basic things about it. And the next thing would be to connect MLFlow. So I'm able to do that by importing the package. I need to set this thing, which is called the tracking URI. So that's essentially a URI to an MLFlow instance. It's exactly the same one that I'm using here to connect to the UI. And then I need to do this. So let's say I'm going to name this Iris. So I need to set the name of the experiment that I'm going to be running. In that, this will be experiment named Iris, and then here by doing start run, I will execute every time I'm going to execute this notebook. I'm gonna create a new run for that Iris experiment. So I can change some of my parameters, like say I can use slightly different input data, or I can do some different feature engineering, right? And each time I'm going to do that and rerun the notebook, it's going to register as a sort of separate entity. So let me now quickly run this and this and this. Now, if before I run this, you can see that I don't really have an experiment named Iris here yet. So if I use this, it's just essentially going to create it. It's there to make our lives easier, right? Not harder. So if I refresh MLFlow now, here it is, Iris, but it does not have any, well, it has the first run started here. It's not finished, it's in progress. Let's progress it. So the next thing I'm going to do is I'm going to grab hold of my input data, obviously. And with that, what I want to also do is I want to register everything, right? That's part of my experiment tracking. So I'm going to call this log artifact and tell it to register the data CSV in the folder called input data in MLFlow. And if I go into that run specifically, there it is, input data, and my CSV data is already here. And then so it goes for pretty much everything you might want to log out. And what you want to log out is definitely, parameters of the model, like this max iteration parameter here, but also the model itself. So as I mentioned, MLFlow has support for many various kinds of frameworks, Scikit being one of them. So I'm able to use this MLFlow sklearn package to call log model, and my model itself, after being fitted here, it's going to get saved in MLFlow in such a way that it's going to be then runnable by MLFlow again, and we'll also see that. So if I now go here, right, I do have my model, and you can see what I'm essentially getting is a pickle file with the model itself and the description of the environment that's required to run this thing. Python version, the dependencies, those kinds of things, right? This is, of course, for the benefit of then being able to rerun every one of those models that I'm going to register if I choose this as my final model. And one other thing that definitely needs to be tracked is some output metrics that I'm going to use to assess the model. So here I'm maybe not super inventive in that I'm just using plain accuracy, but that's definitely worth logging. I'm logging some output data as well, as this is a part of the overall situation. And you can also log tags. Tags don't have any practical meaning as such, but you can use them to basically, put a pointer on some of your experiments. If this is the experiment where you did something important and you want to search it later, you can use a tag for that. So let me now, save this metric and let me run it until the end, so that I'm also calling my end run function, which will end a particular run. And if I do so here, now you can see the run is complete, and I have everything I needed: parameters, metrics, tag that I used, the model, input, output data. And if I say go here and run the whole thing again, then I'm going to generate myself another run under that same experiment. I'm just going to do that very briefly since we lost some time at the beginning. And I do have 2 runs in here, right? So that way you're able to modify your Jupyter notebook and do model tracking in MLFlow directly. And I would say it's a very easy and nice way of doing it, pretty inventive. And once we've run enough, right, then it's at some point we might want to look into those metrics, check the accuracy, choose the best one. Again, very simple example, but let me then take this run and mark this as the model that I'm going to be using for my iris experiment. So what I can do from here is essentially register this model as the outcome of my experiment, right? I'm just going to call this iris model. Right, and then I'm able to register this. And once I do that, I'm able to go here, and you can see there is iris model on the top, which means this progressed to a full-fledged model in my model registry, and I'm now able to manage its life cycle. It really has one version, but I could then, for instance, go and promote that other run to a different version of the same experiment, and I can transition different versions between different states. In terms of what states we have staging, we have production here, and we have archival. Let's say, a thing that I can do is I can take, say, version 1, right, and move it to staging. Now, MLFlow will not run any tests by itself. It's not a CI/CD kind of tool. It's just lifecycle management, but there is already many programs that you can use to integrate it with things like Jenkins. And then on the other hand, you have, for instance, the out-of-the-box integrations with the Databricks version of doing CI. But what's really important is I now want to progress to integration test my model, and then potentially, if that passes, right, to put it in production. So the way MLFlow would do that is you essentially take this model and expose it under a HTTP API. Zero coding, I essentially just need to run one command. So let me run this command in here. The command is MLFlow model serve. I need to give it a port, and I need to say which model. So if you have a look at the end of this line, what I'm going to do is I'm going to say use my iris model, but I'm not going to say use this version on that or that other version. I'm just going to say expose whatever is in staging, right? Okay, let me do that. And once I do that, I essentially will have it on port 5050, available over HTTP. And that's available, of course, for me to show you, but also for all the particular applications like data pipelines, Spark, Kafka Streams, which may want to integrate. So just a quick demonstration. This is my data, in which one row here is just one record of data. So I can send multiple rows in batch, which is a bonus if we're using things like Spark that leverage parallel processing. That would translate to a, say, Spark partition here. And yep, I'm able to send multiple rows of data and get predictions for each one of them. So now let me very quickly finish with the presentation. And we lost some time, so I'm going to try to be fairly brief. Okay, well, that's not the screen I wanted to share, so let me just very quickly switch it up. So we've seen how we do. We've seen very, very quickly how we do model tracking, right? Sorry, experiment tracking, how we can manage the model lifecycle. Now let's, and how we can expose a model under a given URL without doing any coding, right? So the last thing would be to try to integrate it and to try to, for instance, put it together with production pipelines. So if you're doing Spark, that's super easy as shown here. Essentially, Spark, MLFlow just has a library for Spark, which you can use to create a UDF in Spark that connects to MLFlow. So I'm going to say connect to, for instance, Iris model, whatever version 1, like here, or whatever is in staging for Iris model, which can say change in the meantime, but I'm not going to have to change anything. I just have to point it towards an MLFlow URI, which can be name of the model and the state that it's in. So I can connect my, testing pipelines to staging, and I can connect my production pipelines to whatever is in production for that particular model. And then I'm able to essentially apply it, like shown here on the bottom, to, for instance, use Spark to, in massive pipelines integrate with MLFlow and use that Python model to make predictions. And that comes fully integrated with things like, partition level optimizations, which will make it run faster. Yep. And if you think about it, right, Spark integration is nice, but actually HTTP is a super, elastic protocol which anything can access. So say if we wanted to do Kafka streams, okay, there is no such out-of-the-box solution like for Spark, but you're pretty much, you can write one in probably like a day, right? And integrate that MLFlow through that interface into however you're running your data pipelines. So let me just now go to summary. So we've seen very briefly how we can do using MLFlow experiment tracking, how it can integrate with one popular Python library, but you can trust me that it can integrate with nearly all of them in the domain of machine learning, and how we can manage the lifecycle. And that also gives us the ability to deploy the model quickly with zero coding. We know that there is integration with major cloud-based ML platforms. So for instance, if you have an you have your MLFlow on Azure, let's say, you're able to actually deploy using Azure machine learning, which is another added bonus. And that sort of deployment you can use then to test and to productionalize. Now, of course, life isn't always that great in that there are some features which really only exist on Databricks, as far as I know. Like here, you could see I just deployed this on one port on my machine. But if you wanted to do it on, say, Kubernetes cluster with one click, you probably will use Databricks for that, as well as things like, for instance, leveraging some of the features of Spark, which are also only available on Databricks, like, for instance, I don't know, the optimized DB IO, right? And then one thing I wanted to say, because I don't want to be seen as shilling Databricks here, but why I'm saying this and when I'm putting stress on this is I did suffer through putting together some of the custom stacks using MLFlow, and it's not easy and not fun. So there is also the easiness aspect to it, and that's mostly why I'm saying to it. But then there is also stuff we can't do sometimes. So what we can't do with MLFlow, well, it doesn't explicitly have model monitoring module, right? So you probably have to bundle it up with some other tools. It's not difficult to do per se, but it's not explicitly covered, right? And also, MLFlow is quite a concrete tool in that, for instance, has a fairly well-defined model lifecycle. So if you want to have it very custom, I would probably then not use it. And also sticks to things like REST interface. So if I wanted to have my model over custom interface for some reason, which would not be HTTP, then also probably MLFlow is not the best choice. But my experience is it's a very good tool, very easy to use even for a non-data scientist like myself, since I mostly come from data engineering. So I would, generally speaking, highly recommend it. I hope I mostly made it in time. Thank you very much for listening. Yeah, remember to leave some questions and possibly rate me positively if you like the presentation.
Yes, we have one question. Let me find it. Does MLFlow has any components for data drift, concept drift monitoring?
Okay. I don't think it has out-of-the-box tools that would fall into the category of stuff that you have to attach to MLFlow, to your model from the other end. But I don't think there is anything in MLFlow that covers it directly.
Okay, but do you have any ideas what can be used for that?
Yeah, no, I don't want to give out false advice. I can maybe ask some people who specialize more on that kind of things, but yeah, I don't really want to give false advice. Sorry.
All right. No problem. So you haven't been working on this problem yet.
No, that problem not really.
Kamil, thank you. Thanks a lot for the presentation. Thanks a lot for the demo. It worked pretty fine. There were no problems. So that's the most important part, most important thing when you're doing demos. Please remember to rate the presentations so we can provide feedback to our speakers. And we have a short break and the last presentation in front of us before lunch.